Hello everyone. Welcome to this session. So this is unit 5.3 of data communication and computer network. So the topic is IP addressing. Already we have discussed the topic in classroom session, but some part was remaining. Today we are going to cover this topic from start. So what is IP address? IP address is an identifier which identify a particular computer, particular machine or device on a network, on a computer network, on internet. So this is the mechanism, this is the logical address. This is a mechanism to be identified on a computer network. So every machine which is connected on a computer network, it must have a logical address through which it will be identified, it will be recognized on a computer network. Every sender and receiver must have the address. So IP version 4 is a 32-bit address which is used to establish the communication between two or more communicating nodes on a computer network or internet. For example, we are using in our lab, in our college, a class C address like 192.168.10.100, sometime 1.100. You have seen, you have worked with this in practical session also. So IP version 4 have different addressing modes. That is a unicast, broadcast and multicast addressing mode. So we'll see all these addressing modes. Unicast addressing mode, it's a one-to-one communication, means one sender and one receiver will be there. So every sender will contain the destination IP address, a specific destination IP address to whom it want to communicate. So every packet framed to be sent on the computer network or on the internet, it keeps, it holds, it contains the logical IP address of the both communicating nodes. So in this case, we can see client is sending the information to server B, but not communicating with the server A and server C. In broadcast mode, we can see here the client is sending the information to server A, server B, and server C. That will be received by all the servers. The mechanism is that all the IP addresses, the IP address of the destination will contain the 255.255.255.255. It means that this is not a one-to-one communication. This is not a unicast communication. This is the communication of all the machines in a particular network segment. The information will be received by all the machines in that particular network segment. Third one is the multicast addressing mode. In this addressing mode, we can see three servers are there, one client is there. So server B is communicating with server A and server C, not with client. So we can say this one is not unicast, this is not broadcast, but it's the combination of both. More than one machines, but not all the machines being communicated in one instance. So 2, 3, 4, 5, 6, 7, 8, 9, 10 machines can be communicated in a network, but that should be selective. Now, IP version 4. IP version 4 is a hierarchical addressing scheme. Hierarchical addressing scheme means that the address part have some hierarchy. As we know, the IP version 4 is a 32-bit address, and this is depicted in the decimal format with the dotted notations. Every 8 bit will be converted to the decimal value, and that decimal value will be separated with the dot. So every decimal value has some meaning. So that particular address will contain the network address and subnetwork address on host. It's not necessary every network have subnetworks, but for efficient management, we use the concept of subnetworking. One network might contain the several subnetworks. So that IP address will identify to which network we want to communicate, and of that particular network, which subnetwork we want to communicate, and in that subnetwork, to which node we want to send and receive the information. So that is the hierarchical scheme. And we use the decimal values so that we can remember, we can understand the thing very easily. So here one value is written, that is a 10.1.1.1 as shown on the screen. So in this case, there is a separation of one decimal value with another decimal value. And one decimal value represents one octet, 8 bits that is represented. So one octet will keep the maximum value 255 and the minimum value that will be 0. So it will keep the value from 0 to 255. Why this keep only 0 to 255? What's the reason behind this? As we know, there's a 32-bit address, and that is separated in 4 octets. One octet means 8 bit. Here you can see 8 bits represent one octet, and all 4 octets will comprise the 32 bit. So 2 raised to 8. In you have studied in digital techniques, 8 bits represent can represent 256 values. 2 raised to 8, that is a 256. But computer starts the number from 0. So it's a 0 to 255. So all the values, all the numbers that can be represented, that is a 256 numbers, but from 0 to 255. That's why it's a 255 maximum value and minimum value will be 0. Here in this slide, in this screen, we can see we have separated the first 3 octets. 24 bits, that is the network, and last 8 bit, that is the host address. How it comes? This is the network and this is a host. So there is a mechanism. We can keep some values, some bits for the network and some bits for the host. We'll see the different classes of IP addresses on the next slides. So how we can tell the difference between the network address and the host address? How the devices, the routers and all these devices can identify which one is the network address and which one is the host address? There should be some mechanism. For purpose, we use the concept of masking, network mask, which separates the network address from the host address. So first part, we can see 10.1.1.1 converted and the binary values is given and 4 octets are there. So 24 octets, that is stated as network. Why? Because we are using the concept of network mask. Network mask, that is a 255.255.255. Means 24 ones are there. That will separate the network bits, and all the 8 zeros, that will separate the host bit. So here the 8 bit addresses, it will come to 0 to 255. Means that will be the host address, and the remaining 24 bits, it will represent the network address. But all those 32 bits will travel, and that will be contained by one IP address. That is also represented in terms of this one prefix. We can see 10.1.1./24. So 24 network address, 24 bit is treated as a network address, and that shows this IP address has 24, first 24 bit is the network address. It means that 10.1.1 is a network address and dot 1 is the host address of that particular network 10.1.1. So finally the logical address will be 10.1.1. Here we can see the prefix, the concept of prefix and the host that is separated by zeros and ones. We can see in the first part, the prefix contains 10, 1, 1, and the host that is the 0, 0, 0, 0. Means first part shows the network. 0, 0, 0, 0 means this is the 10.1.1.0 is the network ID. And the next part 10.1.1.255/24, it shows that it's a host ID. This network ID also contains the host ID, that is a 255 on that particular machine, on that particular node. So this is the broadcast address. All the ones in the host bit that will show the broadcast. So a start address, a start value 10.1.1.0, that is a network ID. 10.1.1.255, that is reserved for the broadcast, that will not use for the normal operations. Both are reserved. So every network addressing has, every class has or every network has the start address .0, that will be the network ID, and the maximum value 255 in the octet, last octet it contain, that will be the broadcast address. Subnet mask. How subnet mask separates the network ID and the host ID. Here in this diagram we can see 192 IP address is the 192.168.1.152. That is converted to a binary, or we can see 6 times zeros in first octet. Then next octet 1010100000 in next octet, and third octet it contains 7 times 0 and 1, that is the value of 1, and the value of 150 will be 100110000. Now we know this is the IP address of class C. We'll see the later on, all the classes we'll discuss. Class C, and subnet mask of class C by default, that is the 255.255.255.0 if you are using the classful addressing. So that will again converted to a binary, and first 3 octet will contain 81111, means 24 ones will be there in the MSBs, and LSBs it will contain the 0, because last octet will be 0, after decimal that is a 0 that will convert it. Now the AND operation will be done, and finally we'll get the upper address of the 3 octet values of the IP address will come down, because 11 will be 1 and 11, 10 will be 0, and 01 will be again 0. So it will yield. So here you can see the network address is 192.168.1.0, and the network and 192.168.1.152 is the host on that network. So 152 is the identifier or in that particular network of a particular host. So this is the how we can remember, how we can calculate the values. We can compute the decimal to binary. If you know the position number, that is up to you. Okay, how you are going to compute, how you are going to find the decimal to binary and binary to decimal. So positional values, 8th position if it's 1, that's a 128. 7th position, that is a 64. And in the first position LSBs, that is the 1. We'll calculate all these things, then we'll come to the 255. So this is the 2 raised to power position minus 1. 2 raised to, if it's on the 8th position MSB is 2 raised to 8 minus 1, that is 2 raised to 7, and the value will be 128. So in this way, if you have the positional values, if you keep it in mind, then we can compute, we can calculate the thing very, very easy. There's a table which shows the some values 1 to 10 and 16, 32, 64 and 255, the values. If all bits will contain 1, then the maximum value is 255, and if it's all value 0, then it will be 0, and it's LSB this one LSB is, that is the 1, then the value will be 1. IP version 4 address classes. This is a very important concept. Different classes are there, and in this hierarchical model, hierarchical mechanism, addressing mechanism, it contains the different classes like class A, class B, class C, class D, class E. So this is again the representation of the different octets, how the calculation will be done, and how we can calculate the number of networks in a particular class and number of hosts in a particular network. So number of network will be calculated. The number of network bits reserved to 2 raised to number 2 raised to the network bits, that will give the number of network, and 2 raised to host bits minus 2, it will give the host number of hosts. Why we use the minus 2? Why we give the minus 2? Because every network, the first address will be the network ID and the last address will be used for the broadcast purpose, so that in that particular network segment, all the machines should receive the packet irrespective of the source. Class A address. Here we can see the first bit is shown in red color. So first octet, the first bit of the first octet is always set to 0. Oh, then then the value we can calculate 0001 to 011111 means first octet. The maximum values 7 ones, that will give 127. So 1 to 127, 7 ones. If you have the 7 1, if you compute this value, then it will be 1 to 127. So this is the maximum, this is the starting number, and the maximum number in this range. So whatever the number is starting from 1 and that goes up to 127, that will be treated as the class A IP address. So we use 1.xxx.2.126 and .x.x.x means here x will be any 0, 1, 2 up to 255, and the IP range 127 is reserved for loop back IP addresses. Loop back. Every machine, every computer is not assigned the IP address, but that have loop back IP addresses that is used for the various operations, internal operations, loop back servers, and so many operations it will be used. For that purpose, it is reserved for the loop back IP address. And the default subnet mask of a class A IP address is 255.0.0.0, which implies that class A address can have 126 networks, 2 raised to 7 minus 2, and 16 crore, 1 crore 67 lakh 77,214 hosts. That is 2 raised to 24 minus 2. Means we have the host bit 24 and network bit is 7. So network bit is 7, that is a 2 raised to 7 minus 2. Because we are not using the 0 and we are not using this one 127. So that's why is a 126 network addresses. So in terms of alphabet, we can represent for the 0 NNN 7 network bits and 24 host bits. And out of those 24 host bits, after calculation, we can deduct 2 IP addresses that will be reserved for the network ID and for the broadcast IP address. Now class B address. In this address, we can see the first two bits in the first octet is set to 1 0. 1 0. Then the class B IP address range will be 128.0.x.x to 191.255.x.x. And the default subnet mask of class B is 255.255.x.x. So here we have 14 network bits and 2 raised to 14, that is the 16,384 network addresses, means number of networks can be used, and number of hosts will be 16 bits will be used as a host. There are 2 raised to 16 minus 2 host addresses, so it will be 2 raised to 16 will be 65,536 minus 2, that is a 65,532 host addresses, because again I will repeat that first address in that particular network address will be the network ID, and last address that will contain the 255, that will be the broadcast IP that is used. So again the alphabetically value 1 0 and in 14 ends are there, and 16 hosts H is represented. Class C address. Class C address, here the first 3 bit, the first octet of the class C IP address is set to 110. Now 110, so a start value is 192 and the maximum value is 223 in the first octet. 192 to 223. First octet it will contain. So IP address ranges from 192.0.0.x to 223.255.255.x. This is the maximum value. .x, again .x will be the 0 to 255. And the default subnet mask of class C is 255.255.255.x. This is the defined. Every class A, class B, class C has a subnet mask. Class A has 255.0.0.0. Class B has 255.255.0.0. And class C has 255.255.255.0. And class C can give 2 raised to 21 means network addresses. We have the network bits 21 bits. So 2 raised to 21 means number of network, because we have 24 network bits will be there. Out of those we are using 21. Then we can see the number of network increases and grows here, but the number of hosts in each network is reduces, because we have only 8 bits for host, and out of those 2 addresses is being used for network address and broadcast address. The minimum value will be used, the .0 last octet will be used for the network address, and .255 in last octet will be used for the broadcast IP. So alphabetically shown 110 and 21 times N, and finally for host address the 8H is being shown, being used. Class G IP address, there is no subnet mask. Here we can see the first octet will contain the 11110. So first octet, the value from 224 to 239, this will give the class G IP address, and this is reserved for the multicasting address. So multicasting, where we want to communicate with a limited number of destinations. We don't want to communicate each one-to-one or to all. In that case, selected machines should be communicated in a particular network segment. For that purpose, we use the class G IP address, and it has no subnet mask. Class E address, this is used for the research and development purposes, study purposes in laboratories and various educational institutions where the research and development works carries out. It ranges from 240.0.0 to 255.255.255.254, and again it has a no subnet mask, class E. This slide will show the all the classes, address components. Yes, we've seen no specific definition in class D and class E for the network and host and address components. But there's a definition in class A, class B, class C. Oh, here we can say that in the dark, that's 34, that is dark, that is network address. And remaining is a 126.35.124. 125 is the host address. In class B, we can see 134.23 is the network address, that is shown in dark, and in gray 45.123 is the host address. Again in class C, first three decimal values separated with the dot, 212.11.123 is the network address, and dot 3 gray, that is the host address, and that is not defined specifically in class D and class E. Subnetting. In IP version 4, we use the subnetting, the concept of subnetting and supernetting. So classful IP addresses do not provide any flexibility to having less number of hosts per network or more number of per IP class. They have fixed. If you are using the class A, class B, class C, then they have the fixed nodes in one particular network. It will not, the number of networks will not increase. The number of hosts in that particular network will not increase or decrease. That will be fixed. The maximum values. If a class C has a one network 254, then we can't use the 300 machines in one network. And if class B has 65,000 machines approximately, then we can't use 80,000 machines in the class B in one particular network. So that is a fixed if you are using the classful IP address. So there is a term classless inter-domain routing. It provides the flexibility of borrowing the bits from the host part of the IP address and use them as a network as a network bit. So we'll borrow some bits, 1, 2, 3, depending on the requirement, depending on the situation. We'll take the bits from the host bit, and that will be added to the network bit, and it will called as a subnet. So by using the subnetting, one single class A IP address can be used to have a smaller subnetworks. That can be used in one particular class of IP address. So further, here we are dividing. This is in this case, subnetting. We are breaking one bigger network. We are dividing one bigger network in some smaller networks. How that will be done? That will be done through by taking the number of host bits and taking it as the network bits, and we can create the number of a smaller networks, subnetworks, and that provides the better network management. So here in our case example, because as we know the class A has a less number of networks, and every network has a maximum number of hosts. So here we can see the host in one network, that is a 1,67,77,214 hosts per network. So to make more subnet in this class, we'll borrow the bits from the host, and the subnet mask will change accordingly. if you'll borrow the bits from the host, the value of subnet mask will change. So value the subnet mask of class A is 255.0.0.0. That's the default value. But if you are borrowing the bit from the class A host bit to the network bit, then the value will be get changed, depending on how many bits we are going to borrow. For example, if one MSB more significant, we can borrow from the MSBs of the host bits. So one MSB bits, if we are uh, taking from the second octet, first octet that is for the network, and second octet, third octet, and fourth octet is used for the host bits. So from second octet, we'll borrow one bit, and that will be given to the network address. So it creates two subnets because 2 raised to 1 is equal to 2. Already we have the network. Uh, we have identified through the network address. Now the borrowed bit will differ the subnetworks. So if you are borrowing one bit, to 2 raised to 1 is equal to 2. So we are dividing one network into two subnetworks by borrowing one bit from class A second octet, most significant bit, one bit. So with 2 raised to, now the host has only 23 bits. So 23 bits means 2 raised to 23 minus 2. Minus 2, the value will be at 83,88,606 hosts. Almost it's half, less than 2. Matlab, it has a 2 lesser number of hosts. So we are in every subnetwork we are losing two IP addresses as network ID and the broadcast IP. So we have for efficient management, because the managing the network with 1 crore 67 lakh 77,214 hosts, it's very difficult. For that purpose, we use the concept of subnetting for efficiently. Again, if you take the two MSBs of the second octet, then 2 raised to 2, that will be 4. Means we have 4 subnets. And approximate here we have the 41 lakh hosts per subnet. So it shows the combination, the subnet mask. If we have the network bits 8 and the subnet mask is 255.0.0.0. Bits, no bits is better. That's the default value. Because we have the subnet mask 255.0.0 and the bits, no bit is borrowed, and subnet is 1. Then the 1 crore 67 lakh 77,214 host machines can be used. If you have the network bit is 9, means we have borrowed 1 bit. Now you can see here subnet mask is changed. We are borrowing 1 MSB of second octet. So 1 MSB of second octet, the value that is a 128. So now the subnet mask will become 255.128.0.0. And the subnets will be 2. 2 raised to 1 is 2. The machines in per, the host in per subnet will be 83,88,606. If we are borrowing the network bits, 22 network bits, we can borrow maximum 22 network bits. We have to leave, in case of class A, we have to leave 2 network bits available for host, minimum 2 bits, not 1. If you are leaving 1 bit, then 2 raised to 1 is 2. So 1 address will be kept for reserved for the network ID and 1 will be for the broadcast. And no address will be available for the other purpose, for the other machines, other hosts. So maximum the borrowed bit will be 22. So in this case, we can see the subnet will be, how much subnet? Huge number of subnetworks will be there. 41,94,304 networks, subnetworks will be there. And every network will contain 2 hosts per subnetwork. So depending the situation, in which we want how many subnetworks for efficient management, and as per our need and requirement we are going to use. Just we have discussed the why the 30 bits can be contained in the network, not more than 30 bits. Means we have to leave at least 2 bits for the network for a host in every network. Class B subnets. By default, we have the 14 bits used for the network ID, and 2 raised to 14, that gives the 16,384 networks. And every network will contain 65,534 hosts. Means it will contain the 65,536 addresses, but 2 raised to 16 minus 2, it is not 1, it's minus 2. Means we have 65,534 hosts in every network of class B subnet. So again here we can subnet in the same way we have subnetted in the class A addresses by borrowing the bits of the host bit. So here we have the 16 host bit. Third octet and fourth octet is used for the host. So the bits can be borrowed. So these are the possible situation and scenario in which we can borrow the bits. 16 network bits are there. Subnet mask is 255.255.0.0. Bits borrowed is 0, subnet is 0, and host per subnet is 65,534. In second line, you can see network bit is 17, means we are borrowing 1 bit from the subnet, 1 bit from the host. Now we will see the subnet mask value will get changed 255.255.128 because the third octet MSB we are using, we have borrowed 1 bit. The value of that MSB is a 128. So now the subnet mask will become 255.255.128.0. And we have 2 subnets, 2 raised to 1. We have borrowed 1 bit, 2 raised to 1, that is the 2 subnets. And thus almost the subnet per host, the host per subnet will become half, 32,766. A last line. Again here 30. We have to leave 2 bits for the host. Bits borrowed 14. Maximum we can borrow 14 because we have the host 16 bits host. We can borrow 14 bits. Now the 16 and 14, the 30 will become the network bits, and the subnet mask will be 255.255.255.252. Means we have subnets that is a 16,384 subnets because we are using the 14 bits borrowed from the host, and for 2 raised to 14 that gives 16,384 subnets. And every subnet will contain 2 hosts, not more than that. Because 2 bits is there, 2 raised to 4. 2 raised to 4 means 4, 2 raised to 2, that will be the 4. 4 addresses will be there. But first address will be the network address, and the last address containing the last octet as a 255 in decimal value, that will be treated as the broadcast IP. This is the class C. In the same way, class C, all the possible combinations of the class C. Here 24 network bits are there. Subnet mask is 255.255.255.0. Bits borrowed 0, that is the default. Subnet is 1, and maximum host per subnet can be used, that is a 255. If you are borrowing the 6 bits, we can't borrow the 7 bits, we can't borrow the 8 bits. Maximum we can borrow the 6 bits. 6 bits, the network bits will become 30, and the subnets will be 64. And every subnet has maximum 2 hosts. So 2 raised to 6, that will be 64. So maximum 64 subnets can be used, and every subnet will be have two hosts. So here, if you multiply effectively, 64 subnets is there. Every subnet has two hosts. Then 64 into 2, effectively usable IP addresses is 128. We are losing 128 IP addresses. That goes in form of for identifying 64 subnets. We have used the 64 IP addresses, and we have used the 64 broadcast addresses. That is reserved for those specific tasks. That's why we are losing. If you are using the subnetting, then we are losing the IP address. So this is one example of the subnetting, how the subnetting is done, how we can break the network in the subnets for effective management. Here we can see we have used the this one class C IP address. So class C has the default subnet 255.255.255.0, and IP address is 204.17.5.0. So we can create the subnet. If you want to create the subnetting by borrowing the 3 bits from the host. So here the subnet value will get changed. If you are borrowing 3 bits, the subnet mask will be 255.255.255.224 because we are borrowing 3 bits, and those 3 bits will become 1111. That will show the network. Those are from the network bits. Subnet mask, it separates the network address from the host address. So 3 bits is appended to the network address borrowed from the host. Now the 5 bits will be available for the host address. That 000 in subnet address those is for the host address. So by using the subnet mask, we have taken 3 bits, and it is possible to create 8 subnets. Why 8 subnets? Because 2 raised to 3, that is the 8. 2 raised to. So we can create the 8 subnets, and every subnet has 32 host addresses. 32 host addresses, out of which 30 can be used. Effectively, it can be used. It can be assigned because one will be the network ID, and last maximum value will be the whole broadcast IP. Every subnetwork as a first address will be the subnet ID, and the maximum value of that subnet will be used for the broadcast in that particular network segment. So we can create these 8 subnetworks that is shown here. Our address 204.17.5.0. This is the network address. This is the start address. And as we know, 32 we have subnetted. In subnetting, we have used the subnet mask 255.255.250.224. So here host address will range from 1 to 30. 1 to 30. 0 is the IP address, and 31 will be the broadcast address. So 1 to 30. In second subnet, the first IP address 204.17.5.32, it will become the network ID because we have subnetted. Subnet mask will be the same, and host will be 32 is reserved. .5.32, that is the network ID. Now the 33 to 62 will be the host range, host address that can be assigned to the host, normal host, and 63 will be the broadcast address. Third subnet network ID will be 204.17.5.64. So it has the IP address range, host address range, that will be 65 to 126. The last row, we can see the subnet ID is a 204.17.5.224 and the subnet mask is 255.255.255.255. It will subnet for all the subnet. Now, the host address range will be 225 to 254. So this is the illustration of subnetting, how the subnetting is done. So it can be denoted in this way also, because we have taken 3 bits from the host address, and this subnet mask has become 255.255.255.224. So 24 plus 3 subnetted bits borrowed from a host, it will become 27. So now the prefix will become 27. So 204.17.5.32/27, it shows that the start IP address is the network ID 204, that is the subnet ID 204.17.5.32, and the subnet mask is 255.255.255.224. So this is the second range. This IP address is the second. This is the second subnet. So this is the diagram to be shown here. Various routers are communicating the different subnets with a different ranges through the device. We are communicating, and for effective management, we use for the different each and every department as per the need or requirement. We can create the subnet. We can manage them effectively. We can secure them by using the concept of subnetting. So we'll do one exercise on the subnetting. So 2 devices are there, device A and device B. Device A have IP address 172.16.17.30/20 and device B 172.16.28.15/20. So by here we have to identify, are they from the same subnet or from the different subnet? Why we are calling the subnet? Because if you are not using /20, then it will be clearly the IP address of the class B. Both will be the IP address of the class B, and that may belong from one network. But here /20 means we have borrowed some bit from the host. Now the network bit has become 20. By default, in case of class B, it has a 16 network bits and 16 host bits. So we have borrowed 4 bits from the host. Now we have subnetted. So now we have to identify, are these 2 addresses of the same subnet? So first device will compute in the binary. So 172.16.17.30 will be converted and will get the binary value. Now we have borrowed 4 bits. 4 bits 225.225.240. 4 bits. 4 MSBs of third octet. That is the host bit, but that is borrowed. That's shown in the red. So 4 bit. Now those 4 bit value will be 240. Means 1111 and 4 times 0. Its value will be 240. So subnet mask will be 255.255.240.0. Now when we'll use the AND operations on these 2 ANDing, then we'll get 10101100.0001000, then 00100, and finally 00080. Last octet will contain 0. Because the subnet has 0, then we'll get the 0. So whenever the both have the 1, then it will be 1. Otherwise, anyone the bits will be 0, then it will be 0. Then finally, when we'll convert this value in decimal, this will be 172.16.16.0. So this is the subnet ID 172.16.16.0, and we have borrowed this one 4 bits, means 2 raised to 4. How many subnets will be there? There will be the 16 subnets. But we have to see either the device A or device B belongs to the same subnet. So device A belongs to subnet 172.16.16.0. Now we'll see in the same fashion, in the same way, we'll determine the subnet of B. We'll compute both the values in the binary. We'll convert the 4111, that is the subnet value. Again, we'll convert after doing the AND operation, we'll get the value 172.16.16.0. So both addresses, both subnet is same. So we can say both IP address belongs to the same subnet. This is another concept, supernetting. This is just we can say the reverse of the subnetting. In subnetting, we are dividing one larger network, one bigger network of same class in a smaller network. Here, we are combining a smaller network of one particular class address into one bigger network. And how that can be done? In case of subnetting, we have borrowed the bits from host. But in supernetting, the bits are borrowed from the network and that is given to the host. So we are increasing the number of hosts in one particular network. In case of subnetting, we are decreasing the number of networks. We are increasing the subnets, more number of networks with less number of hosts. Here, less number of networks with more number of hosts. So it has so many uses. Why we use the supernetting? Supernetting has the two basic use. And two basic motto aim behind the supernetting is that routing, updating of the routing tables consumes a huge amount of network bandwidth. And for each and every IP addresses, the network routing table has to be updated and they have to record those things in routing table. But in case of if same type of addresses with the common bits are coming, then that can be updated with a one entry by using the concept of subnetting. So we can lessen the burden of the routers. Another use is that depending on the need and requirement of these machines, we can combine the class C, so many class C networks in one bigger network. Instead of using the class B and class C, we'll discuss what are the advantages of using the supernetting. Supernet mask is the reverse of the subnet mask. In supernet mask, we change some ones in the network ID section to 0. In subnetting mask, we change some zeros to ones, but here we are changing some ones to the zeros. Subnet mask in supernet mask. These are the steps, these are the procedure, how the supernetting is done. First, we'll identify or list the networks to combine. We have to see which one network we want to combine. Ensure that all the networks are of the same class. We can use when we are combining the various networks, then it must be from the same class. Class B and class C can't be combined. Class C and class A can't be combined. So we have to keep from the same class. And convert all the IP addresses to corresponding binary format. Then find the common prefix from them in the binary format, and common prefix means the set of matching bits sequence from left to right. We'll come and know how many number of bits in all those network is same and common, and we separate that one, and that will become prefix. That will become the network address. So here the network address will become lesser and the number of hosts will increase. And set the remaining bits to 0. We'll set the remaining bits to 0. Now the network will grow because it will contain the more zeros, means more hosts when we'll compute those things in terms of when we'll assign the value. This is the example of supernetting. So here we have considered the three Class C network with the following addresses: 192.168.98.0/24. 24 shows up as a Class C address. Second is the 192.168.100.0/24. Third is the 192.168.105.0/24. So when we'll convert in next part, you can see we have converted these bits in the binary numbers, these IP address in the binary numbers, these network address in the binary numbers, 192.168.98.0. And we can see these three addresses have common bits that is shown in the red. We have separated the common bits. Now 20 common bits are there. After 20 bits, the bits is going to change. So 20, we have separated 20 bits. Now that will become the network bits, that will become the network ID. So as we know, by default, 3 octets are used for the network ID, and last octet 8 bits is used for the host. But here we have combined 3 networks in one network by selecting the common bits and calculating those bits, converting those bits, and as per those bits, the subnet mask will also get changed. Now here the net mask will become 20 bits instead of 24 bits because 4 bits has become 0. That is 0. Now those zeros will be appended to the host. Now the host has become 12 bits. 12 zeros, 12 bits. And the subnet mask has become 255.255.240.0. Instead of 255.255.255.0, we have the subnet mask 255.255.240.0. Note that the subnet mask has been reduced to 20 for the Supernet. Here, Supernet, the mask has become subnet mask, network mask, not a subnet mask. We can say the network mask has become 20, which will identify the network address and the host address. When to use? This is a real-time situation scenario in which we can use. Suppose that if you want to use the 300 computers, for using the 300 computers, we can't use the Class A address. We can't use the Class B address because the Class A address in one network it uses 1,67 lakh computers. If you are using 300 machines, then the rest of IP addresses will be wasted. If you are using the Class B, then we have one network, we have 65,534 hosts. So in that host, we are using only 300 machines. Now we are losing 65,234 IP addresses. We are wasting those IP addresses. So here we will combine 2 Class C IP addresses, which will contain 254, means 508 IP addresses will be there. 508 IP addresses. So simply we are wasting only 208 IP addresses. But in case of Class B, we were wasting 65,234 IP addresses. We have to preserve the IP addresses for the use of the various companies, organizations. So we'll not use that one. We'll combine the IP addresses of this Class C. 2 networks will be combined, and that will be done through the concept of Supernetting. Second one, if organization needs 1,000 computers, again here if you are using Class B IP addresses, then we are losing 65,534 minus 1,000. We are wasting 64,534 IP addresses. Again, here we'll combine the 4 IP addresses. 4 networks of the class C. The 4 into 254, that is a 1016. So, how many IP addresses will be wasted? 16. Only 16 IP addresses will be wasted. Then no problem, no issue. For that purpose, we are using the concept of supernetting. We are combining the smaller networks and we are creating the bigger network as per our need or requirement. And we can combine the IP addresses from the same class. So here the advantage of supernetting is that we can prevent the wastage of the IP addresses. And if the wastage of IP address means exhaustion of the reserved class B IP address, that is a reserve. Class A is also reserved. Class A is public. Hence, we can conserve the IP addresses by using the concept of supernetting, which one will be used and how it should be used. Classless addressing. The classless addressing, as in case of classful addressing, they have the fixed subnet mask, but the classless IP addressing, the number of bits in the mask is going to change. In case of classful IP addressing, 192.168.0.0/24 defines will be treated as a classful IP address having 255.255.255.0 subnet mask. But here, CIDR, classless internet domain routing, address of 192.168.0.0/24 defines a block of addresses in range 192.168.0.0 through 192.168.0.255. While 192.168.0.0/20 will define a network 16 times as large, that is 192.168.0.0 through 192.168.15.255. Now, it's a more bigger network because it has a more number of hosts compared to the previous one. Here we are using, so this is the same address. The same address will be used for in classless internet domain routing. We are combining the more number of networks. If you are using the 20 bits as the network addresses, means we are leaving the 12 bits for the host address. If you are using the 24 bits of network address, we are using the only 8 bits for host address. So here we are combining the networks and we are creating the more number of hosts in that CIDR mechanism. There is an example. If you have a /10 prefix, means we have 4 million hosts. Now, number of network bits is 10 bits and host bit will be 22 bits. Then 4 million hosts will be there. If you have 19 bits of network, then 8,119 hosts will be per network will be used per network. Host bit will be 13. If you are using 20 network bits, then host bit will be 12, and each network will contain 4,094 hosts. If you are using 24 network bits, then the host bit will be 6, and we'll use this one. How many hosts will be used? 254 hosts will be used. 28, then the host bits will be 4. So we can, this is the classless IP addressing, classless addressing, in which there is no fixed subnet mask. The subnet mask will change accordingly when we are borrowing the bits of the network to the host. Means we are increasing the number of hosts in one particular network by combining several networks. So in this CIDR, we normally it's being used with the class C addresses. When these class C addresses are used in one routing table with 256 entries. But if you will combine the several class C addresses, then the routing entries will decrease by combining the various common bits and reducing the network bits, increasing the host bit, so that very lesser entries contain will contain the routing table. Classless internet domain routing. That's why it's called. So CIDR, if you'll use the without supernet mask, if routing table without supernet mask, individual network addresses will be there. Default subnet mask 255, 255 for every one network addresses x.y, whatever x or y value will be 32, 33, 34, 35. X is same, y is same, and all the addresses first two decimal values will be same. Now normally, and only it's changing in the next decimal value. That is the 32, 33, 34, 35. Now, when you use the concept of supernet mask, it will contain only one entry. Instead of four entries, the routing table will contain only a single entry. So this is the benefit of supernetting. This is the benefit of CIDR. Now we have a question that was asked in the MSBT examination. Site address is a 201.70.64.0. The company needs 6 subnets. Now we have to design the subnets, write addresses of all subnets. How will we design? This we'll see, we'll explore how it can be done, how it will be computed. Site address is 201.70.64.0. We have to find the 6 subnets as per our requirement. And it belongs to the class C. It's of class C, of course, 201. It's of the class C. Default subnet mask is 255.255.255.0. To design 6 subnets, we have to borrow how many bits? We have to borrow 3 bits, because 2 raised to n means 3. 2 raised to n, that will be 6. So we have to borrow 3 bits from the host. Now we'll compute the different subnets. So IP address is given 201.70.64.0, and we have taken the 3 bits from the host. Now the first combination will be here, because the value of the first 3 bits will be 001. So 001, taking last octet in the binary 001, and now 5 zeros. This is the 32. 32 in decimal. So the subnet address, the first subnet address will be 201.70.64.32. Second subnet will be 010, because the value will be changed, taking the last octet in the binary 010. 010. This is for 3 bits our combination which we have borrowed. 010 and the 5 zeros, that is the 64. 01 and 00000 will be 64. So when we will convert this one in the decimal, it will be 64. Now the subnet address is 201.70.64.64. So this is the second subnet, first address of second subnet. Now see the subnet 3. The bit combination is 011. So taking last octet in the binary 011 and 5 zeros, that is the 96. So then the address of the third subnet will be 201.70.64.96. This is the first address of the third subnet. So this is the network address of that subnet. Now subnet 4. the bit combination will be 100 because we have borrowed the 3 bits. Now the bit combination will be 100. Taking last octet in the binary 100 and 5 times 0, that's a 128 in decimal. Hence the subnet address will be 201.70.64.128. Subnet 5, the bit combination will be 101, 3 bits, which is borrowed. Again, I am repeating again and again. So taking last octet in the binary, 101 and 5 zeros is equal to 160 in decimal. Hence the subnet address is 201.70.64.160. Subnet 6, the bit combination is 110. Taking last octet in the binary, 110 and 50 is equal to 192 in decimal. Hence the subnet address is 201.70.64.192. So this is the address of 6 subnet. We have to calculate, we have to compute in this situation, in this case, the address is given 201.70.64.192. So these are the 6 subnets. So finally, this is we are going to conclude here. So I hope that you might have got the concept very well. Go it again and again. If you have a doubt, then you can contact me through the WhatsApp, through the social media, and we can get clarified. If it needed required, we'll keep some live sessions also, so that we can come across, we can clear your doubt in those sessions on the social media. Okay, thank you. Have a nice